All right, I have a jumper wire there that jumps the phase output from this first phase leg straight to positive. I am turning on the low side IGBT. This is a 600 amp, 1200 volt rated IGBT. I'm turning it on into a dead short with 456 volts charge. I have a fuse that's 400 and something amps rated, 475 amps rated, and a circuit breaker, I believe is 60 amps rated. My heart is going right now. Anyways, I'm trying to test a dead short to prove if the IGBT can last. I put some 600 amp rated IGBTs in there because they are very similar to the 800 amp rated IGBTs I was using, and they're a lot cheaper, so I can test with them. When I can prove the system works properly, I will move back to the more expensive 800 amp IGBTs. There's no harm in running these to get the motor running and everything because it'll still do some pretty decent power, but once I'm ready for the big power, I'll go back to the 800 amp rated IGBTs as I develop a whole other controller. So I've got myself prepared with some safety glasses, face mask, and a set of earmuffs on because this might be loud. Anyways, I'm going to try the button. I heard a pulse. See nothing on the scope. I can tell it's working. Heart's going. Can't see it on the scope. Not sure if this is too low or too high. One more. Every little noise in the shop here scares the crap out of me. I'm just going to try and set the trigger up. Right there. There we go. There's a dead short. I need to scroll back my blue trace, which is the current. That means I need to bring this up. Something like that. I have a very short pulse set right now. Let's see. So that cursor's there. That cursor's there. That's somewhere around 1300 amps. We can work the math. Calculator. Sorry, I got to do the math a long way. 2.3 clear. What I'm doing right now is calculating my current sensor calibration. Damn it. So it's 2.3 millivolts per division per amp at 8 volts input. But I'm running 12.8 volts input, and then I'm dividing it by 2. So it's 1.84, and we have what? 2.38. So clear, 2.38, 1.84. So that's basically just under 1300 amps. So this little dial turns up my first pulse. I'm going to turn it up just a smidgen and see what happens. There we go. So it's not really going any further. If you zoom out, I believe this first off shoot, that's 1, 2 offs. I believe what's happened is it's hitting Desat and shutting itself down. Now, this is really a bad idea, but to prove it, I'm going to turn it up a little more. Nothing's changing. Oh, I believe we see 1, 2, 3, 4 off events now. Now if I turn it back down, those should disappear. Yeah, now we only have 2 off events. So this thing is surviving a dead short. Now the short does come through a wire right here, comes around, loops to this phase wire right there, and then it comes through this loop back to the thing, so or to the cap at positive. So there is a bit of circuit inductance to that. The next, I'll just grab a flashlight. The next setup, the next test, I'm going to put a bridge right down there. You can see the high side IGBT. I'm going to put a jumper shorting that out with a piece of solid copper right across the high side IGBT. But this is reacting essentially fast enough. These 600 amp rated IGBTs, I don't know if I have them in this data sheet here. No, I don't. But the 600 amp, we'll open this, rated IGBT, just get there. The 600 amp rated IGBT, I believe is 1600 amps in this spot. I believe 1 millisecond pulse. It might be different, but it's a little lower than this is the 800 amp rated data sheet. So nonetheless, it's actually within its safe zone. So the Desat is doing what it's supposed to, and it's saving it. That is a really great thing. So I have an issue with a couple IGBTs that popped recently, and I have the Desat set up really well, I believe, but there could be other issues that cause it to pop. I'm going to shut this off before I get hurt. Shut this off. So now you can see the voltage dropping. I'll let that do its thing for a bit, and then I sometimes use a double pulse tester to pull it down quicker. I have this just discharging resistor, ceramic, whatever you call those, resistor, ballast resistor on there, because it's actually the factory leaf bleed down resistor. So I got that on there to safely bring that down slowly. And nonetheless, I think everything's good so far. So now I need to move on to the next thing for debugging this. This thing should actually run really well once I finish debugging it. I will get there in time. It's just a tricky thing. And you know, one of the things I actually remembered doing was I forgot 2 phases disconnected. I'll walk around to the other side, but I have phase wires that come out that I left disconnected. And one of them was this one right here. I left that bolt out. And then there's one for phase 1. I left the bolt out, and I tried running it. So that might even have caused all my issues, but trying to diagnose something, you know, I was excited. I was putting things together in a hurry. Who knows? But either way, making progress.